So now let me start. Okay. Okay, thanks a lot for the hosting, and it's great honor to have a talk here. So today I will give a talk about our works on the Apache Gravitino and to see how to use Apache Gravitino to build a catalog context and use this context to power the development of data agent. So our company, Datastrato, we begin with solving the data silo problems because we saw that data is siloed, but not just by different data stacks because of the different usage scenarios, but also is siloed by different cloud providers because of different reasons. For example, like cost saving or like network for torrents considerations. And even more for big companies, data is siloed geographically because of the international business and because of the regulations and the policies of the different countries. So data cannot be transferred across the borders. So data is siloed by naturally geographically. So as you can see, data silo problem is a long-lasting and hard to tackle problem. And it is now even more severe because of the different cloud providers and also the different regulations and policies. The traditional way of solving the data silo problem is to try to move the data altogether into a one centralized storage, for example, like data lake technology or lakehouse technology. But uh, it is more challenging when we meet the multi-cloud, multi-region, multi-cloud, and multinational users. So we are thinking of using a new way to solve the data silo problems because we thought that each data should have metadata. So instead of trying to solving this problem in the data layer, we are seeking of trying to solve this problem in the metadata layer. So inspired by this idea, we started our new project, which is called Apache Gravitino. Apache Gravitino is a unified catalogs, and we call it catalogs of catalogs. And because it can manage the metadata from different catalogs. For example, it can manage data from the traditional Hadoop data lake, or the data warehouse, or the or like data from like MySQL, and all data from like model registry, and Gravitino unified all the data together and also define in a unified way for the users or for the app level applications. And for the users and the applications, they can fetch and they can access the metadata in a unified way. And in such way, we can unify the data altogether from the metadata aspect. So we call it metadata lake. So Gravitino has several key features. The first important feature is a single source of truth from the metadata level. So we provide a federated, unified view of the metadata, so we can achieve the single source of truth. And also, Gravitino can support multimodal data management. It is not just the traditional tabular data, but also the unstructured data like the files, models, and others. And we can manage them all together. So it has the ability to manage AI data. So it is by nature the combination of it is by nature a multimodal data catalog. And also it can support geo-distributed architecture, so it can manage the data across the regions and across clouds, because we saw that the data is separated by region and nature, by region uh, and by clouds, and we're trying and we our goal is to solve this problem in a unified way, so we can deploy geographically and also unify them all together to give a user unified access of the data. And beside this thing, because we provide a unified view or unified access of the data, we can also manage the data on top of it. So we provide a centralized governance and security in one place and within the Graphtino. So with this, we can manage the data all together, provide a unified and federated way to see the data across the stacks, across the region, and across the clouds. So Graphtino, since its start, we have developed more than 2 years, and so far we have achieved a lot compared to other open source catalog projects, and we have achieved a lot. And for example, we have supported like catalog federations and also multimodal data management. And we also have the built-in ISO-based catalog service support, which is a full functionality on ICC. And also we can support most of the mainstream open source query engines like Spark, Trino, and Flink. And we have the fine-grained access control and other governance things. And we support lineage and auditing. So we in all the aspect from the technical metadata to the business metadata, we support a lot of support a lot of features compared to the Apache Polaris and Unicatalog open source. So this is all belong to the contribution of the communities, and we have a lot of community members who are using and who are improving our project, and we thank to the community members who continuously contribute to our projects. Without your contribution, the project cannot moving so fast. And we also highly embrace the open source. And since the day one, Graphtino is open sourced, and we have also donated our project to the Apache Software Foundation in the last year, in the June last year, and within the community government within the governance in the community for less than 1 year, we have already becoming a top-level project, graduate from the Apache incubator in the May in this year, and we still moving our pace fastly. And in this month, we achieved the milestone of the Graphtino 1.0, and we think that as the milestone on the 1.0, we have achieved a lot in the catalog things. So, so what is the next? So let's go back to the reality. So the first thing we saw that in the reality is that the returns or the ROIs of the pursuing 3Vs are diminishing. So what is 3V? 3V is the velocity, variety, and volume. This is three metrics in the big data area, and for the decades we are pursuing these 3Vs to make the architecture or make the cluster running faster and has a large volume and also support a variety of data. But as you can see with the development of the hardware, for example, in the left two charts, with the increasing of the storage density and the network bandwidth. So for nowadays, we can easily build a very large scale data storage cluster by just only several nodes and with the high-end storage machines. So we don't have to develop a very sophisticated distributed algorithms. We can easily using the machine hardware's power to build a very large volume data storage, and which makes the pursuing of the volume is easy, tenable. And so currently, we don't have to put a lot of efforts on building the very sophisticated distributed architectures to achieve these things. But on the contrary, with the end of the Moore's law, currently for the CPU, the single thread performance is uh, cannot cannot increase continuously. Also the frequency of the CPU. So which makes the performance gaining become harder and harder. Nowadays, we have to write very sophisticated native code, even the CPU-specific instructions to gain the CPU performance. So which means the pursuing of the velocity becomes a very hard. And this means that with the development of the development of hardware, so nowadays pursuing of 3Vs, the IOI is quite lower. But in the opposite, and the management and operating this data stack is becoming more and more complex. And here is a chart from the A16Z, which is called modern data architecture. So as you can see, there are a lot of components for different purposes. And for most of company, if they want to build their own data architectures, they will more or less introduce this kind of components. So it becomes more and more complex, not only for the users like data engineers, data analysts, and scientists, and data steward, but also for the maintainers like data ops engineers and others. So this against how things developed. Uh, by nature, we want things more powerful, but more easy to use, but not more complex. But currently, we're still pursuing the complex architecture of the data platform. So let's take the another automobile industry as an example. So uh, as you can see within the centuries development of the automobile industry, so nowadays the consumers cars become quite mature. So for most of the companies, they can easily build a car without needing to with a quite mature industry. So for now, for the consumers, for most of the consumers, do we want to pursue a speed car, much more fast car with very complex controllability, or we want an autonomous car without a steering wheel? So for most of the consumers, I think we want things more simple. So uh, even we want a car can drive itself. So this is the how the automobile industry evolves. So I think it also can applies to the other industries like data industry. So we think that the next generation data platform should be a AI-driven intelligent platform. And in the center of the architecture is the AI-powered knowledge base, which we call data brain. And we also have a lot of handy tools and build around this data brain. And this data brain can use these tools easily and for the domain specific requirement. So with this, we build a AI-driven intelligent platform. So as we brought out a intelligent platform, so let me show you an example or demo of how it works or how we want to build it. So let's see a quite uh, let's see a, a realistic problem. So this is their daily work for the data engineers. They want to their daily works build data pipelines, and typically they will give the requirement from the businessman, and then according to the requirement, they will try to explore the related data and build the pipeline and test and verify the pipeline. And after the pipeline is formalized, they will generate the DAG. DAG is a DAG is uh, for example, like Airflow DAG, and then submit and run. So this is a typical daily work of a data engineer. And and for the if we introduce the intelligent platform, so how do we change the whole pipeline? So for now, if as we introduce the AI, so we can leverage AI to do most of things. Here in this demo, I built two agents. One is meta agent for the metadata discovery, and also for the query generation, and also for the query agent, which is mainly for the query execution. And with this, and data engineer can talk the requirement to the LLM. LLM will dispatch this and separate the workload and dispatch the works to the different agent, and agent will try to collaborate and to fulfill the task. So let's see the how it works. So here is the UI of the Gravitino. So I have a lot of sales table in the sales department. This demonstrates the scenarios that the sales details, sales informations are recorded in the database. So I have a requirement to calculate the top 10 sold products in each year. So based on this requirement, I have separated down into the several steps, like analyze the table and also do the validation and build a pipeline, and then the formalize the ETL pipeline and submit to the Airflow. So also with this, the large language model, we were trying to understand my requirement and using the agent and handy tools to code the Gravitino to get the metadata, and using metadata to analyze and generate queries, and also to formalize the DAG. So the first step is to analyze the related table based on the requirement. So it will try to get the structures and schemas of all the related tables and the columns in the sales department. So after the analysis, and he will figure out the relationship between the tables and the primary key and the foreign keys, and with this, he will try to the large language model will try to generate the data validation sequence, because this is a raw data, so we have some uh, anomaly data. So we need to clean that data before we build the pipeline. So it will try to build the data quality um, analytics and generate the report. As you can see, there are some non-values, and the unique sales ID is only just 22. So there are some duplications. So then we are trying to build our data pipelines using medallion architecture. So we will first build an ODS layer, trying to uh, also the bronze layer, using the SQL to generate a bunch of table and insert and also insert the table, and then we'll build a silver layer, and then the gold layer. And then we will do the ETL things, try to load data from layer to another layer. Yeah, it continue this continue to load the data, and then for the gold layer, it will try to aggregate the all the data together to give the result of the top 10 sold products year by year. So as you can see, after the execution, we have built different layers for different tables, and and so that we build a pipeline. And for the final step, we generate the Airflow DAG. So this Airflow DAG will be submitted to the Airflow to run daily, and which is a finalized ETL the pipeline for this requirement. After all the tasks done, then it will give us a summarization of the what did it do. So so this is a demo of the how we build a intelligent platform and use this intelligent platform to fulfill our requirements automatically. So so how do we do this? So what is the next generation intelligent data architecture, and how do we do this? The first thing is that we think that the metadata is the key for the next generation intelligent data architecture, because metadata is the data of data. So LLM cannot understand the structured data or just numbers, but the metadata can explain the details. So metadata is the data of data, data about data. Also, it has context understanding and discovery informations for LLM to understand the context, and also it has the coordination and governance ability, and which can make the decision making and automation. So metadata is a bridge between the LLM and the data. So with this metadata and the LLM, we can build a data brain. And so here is the architecture of the intelligent data architecture. We build a unified metadata layer and powered by the LLM to build a data brain. And we also make the different kind of tools. We build different kind of tools, make them agentic. And so for the users, they can talk to LLM. LLM will invoke and use this invoke these different agents and also different tools by and to fulfill the task. So this will significantly simplify the usage and even the maintenance of the data architecture. So how do we do this in the Graphtino? So as we already introduced, Graphtino is a catalog of catalog, which means it can manage the metadata uh, around, uh, around the company, and so we have already built a knowledge base for the company's data. And with LAM, we just built a data brain. So for the next step of Scraptino, we are focusing on several things. The first thing is that we will enhance the metadata to add more metadata like statistic for the this is to enrich our data brain. And also we are building the different actions and policies, and this is for the data brain to trigger the task, and to using the tool to trigger the task. So like the arms and the legs. So we have already have brain, and now we build arms and legs. So with all of these, we can build this intelligent data platform. And also we will power them by the AOLM to make all of them agentic. And so in Graphtino currently, we will build several agents, for example, like metadata agent. It is for the data discovery and context understanding. And we'll also have the policy agent. It's kind of like a guardrail for the agent, and it can build the check that and build and check and build enforce the policies on the agent. And we also have like action and job agent to generate jobs and run the jobs. So with this atomic agent, we can build different scenarios and we can support different scenarios and build data agent. For example, we can build agent for the data ops, data engineer, data science, and data governance. So, so for the next step after the 1.0 of Gravitino, our goal is moving just from the catalogs to a more broad vision to uh, to add the more to adding the building blocks for the data agents. So we are currently working on step by step. The first thing is about building the knowledge base. We are adding more metrics and statistics support in the knowledge base to enrich the knowledge base. So we can build a, a more smart data brain. And also we are continue building the action framework to add the jobs and functions. And these are all the handy tools for the LLM to call and to leverage. And we are also, for the third step, we are building the policy enforcement, which is guardrail for the LLM and agent. And we are continue to working on these things. And we are also uh, welcome the community to contribute on these things. And and we have already released some of the components in the 1.0 version, and we will continue to adding more functionalities in the next release. So please stay tuned. So if you are interested in our project or in our company, you can scan our QR code. Also, you can watch our project Gravitino and stars if you liked. Okay, that's it from my side. Thank you.